Okay, so this is 8.5, and this is where we're going to do a hypothesis test for the variance or standard deviation. It's the same process. It's just a question of whether we're checking the variance or checking the standard deviation against the chi-squared distribution. Now, this is one where we can't use our calculator to do the p-value method. Everything has to be done by hand off the chart. Obviously, we use our calculator to make some adjustments and some calculations. First thing you need to understand is that the test statistic for chi-squared is going to be this formula. N minus 1 times S squared, S being the sample standard deviation. When it's squared, it's the sample variance. So if you get the standard deviation, you'll have to square it in this position. If you get the variance, then it's already been squared. And that's divided by the population variance or population standard deviation squared. Now, one thing to keep in mind, this sigma down here at the bottom is really our null hypothesis. So what do we think the standard deviation is squared, or what do we think the variance is? And that'll be in our null hypothesis. We're going to use the traditional method. We can use the p-value method, but it has some issues with it because we can't know the exact p-value when we use the chi-squared table. First thing we do is always state the hypothesis and claim. That doesn't change. We find the critical values from the chi-squared distribution. Then we will compute our chi-squared value, make a decision to reject or not reject. The rules for general rules are, when we look at this table, if it's a right tail test, then we can use these right values. And you can see when we zoom in a little bit that the 0.1, 0.05, 0.025, 0.01, those values there are our alpha values if it's a right tail test. If it's a left tail test, all we have to do is find the corresponding side. So if column D is a 0.05 right tail test, then column D over here on the left, the 0.95 is the left tail test for 0.05. And if it's a two-tail test, we have to split the alpha in half, okay, and then find those two values. The right tail will be whatever alpha divided by 2 is, and then the left tail will be its corresponding column on the left side. Let's take a really simple example of how to do this, and we're going to use the traditional method. We'll talk about how to use the chart to find the p-values. I think there's one question where you have to use the p-value method, or at least understand how the p-value method would work. When we start into this hypothesis test, instructor wishes to see whether the variation, okay, in the scores of 23 students, so that right there, 23 students, that's going to be N, students in her class is less than the variance. Okay, variance tells me I'm talking about sigma squared, not sigma. It wants to know if it's less than. Okay, so less than is important. The variance of her class, okay, that would be S squared, is 198. Is there enough evidence to support the claim that the variation of her students is less than the population variance, where sigma squared is 225 at alpha equals 0.05? So null hypothesis is going to be that sigma squared is 225. That's the population variance. We want to look at her discussion, and she's talking about it being less. Her class is maybe less than that. So sigma squared would be less than 225. And it says, is there enough evidence to support the claim that hers is less? So we'll make our claim the alternate hypothesis. What we need to do now is determine our critical values. Because this is a left tail test, when we think about the graph, there's going to be some number that creates this boundary over here. I'm going to go to my chart. Now, we had 23 people in the sample, and we're looking for 0.05, but it is a left tail test. So first thing I do is I'm going to figure out with 23 people that the column, or that the row 22 is going to be my row. Now I'm looking for 0.05, which is column D. I'll do the left column because it's the left tail, and that gives me the 12.338. I'll come back here. My critical value is 12.338. I now need to get my test statistic chi-squared. which is n minus 1. I'm going to remember that formula you should have in front of you. N minus 1, that would be 23 minus 1 times s squared. The sample variance was 198. If it had been given the standard deviation, I would square the standard deviation in that position. And it's divided by the population variance, or our null hypothesis, of 225. If we plug those numbers into our calculator, take just a second, it'd be 22 times 198, whoops, 22 times 198, and I divide that by 225. Excuse me, I'm missing buttons. 25. And I evaluate that, I get 19.36, which, if 0 is over here on these chi-squared, it always starts at 0 and builds up from there, then 19.36 would be over here somewhere. So I'm going to not reject H naught, and I can say there is not enough evidence to, and we would be looking at support the claim. Now in your homework, I think on question number 2, it specifically says, you know, if I had to use the p-value method, how would it work? Okay, so the p-value method, you would calculate a test statistic, and let's say that your chi-squared that you calculated came out to be 16.32, something like that. It's a left tail, and you were told that your number, that your n was 27. How would you figure out what p-value you'd be using? Because the calculator gives us the p-value, but when we don't have the calculator as an option to produce that p-value, what are our choices? You're not actually going to find the p-value, but you're going to find a place that p-value fits between. And the way this works is we actually go down on our chart to the degrees of freedom of 26, okay, because n was 27, we go to 26. And then we're just scanning to find this 16.32. We're not going to find it, but we can find where it fits between. This one's just smaller and this one's just bigger. So it must be between these two values. If I scroll up, the alphas for those, okay, and I can use the purple ones over here. I can use the ones on the right side to get the decimal, because it's 0.9, that means it's actually 0.1, because it's always 1 minus that when you do the left side. But we could say it's 0.1 and 0.05. What that means is that the p-value, while I don't know what it is between the smaller 0.05 and the bigger 0.1. I don't know the p-value, but I know it's between 0.05 and 0.1. So if someone did come along and said alpha was 0.05, I don't know p-value, but I know that it's bigger than 0.05, less than 0.01. And if that was the case, okay, that p-value is too big for this alpha, so I would not reject. Okay, it leaves some ambiguity. I don't actually know p, but I know it's in between these two values, so I can make some comparisons. Okay, all right, good luck guys, we'll see you in class.